All right, guys, here we go with my sample 2 problem for April 20th through May 1st. This will be very similar to your number 2 problem on the assessment problems for Module 4 that I assigned for this week. Okay, so problem 2 on my example says, Jack drives his car at a rate of 60 miles per hour. Below is a table that represents the number of hours and miles that Steve drives. Assume both drivers drive at a constant rate. Use a form of the distance formula. Then in parentheses, I list the 3 forms. The first form is D equals R times T. Second form is R equals D over T. And the third form is T equals D over R. D stands for distance, R equals your rate or your speed, and T is your time. Okay, so in my table here, you see that in that first column, it's time in hours, which is X. My second column is labeled distance in miles, which is Y. And then you see that the 4 entries I have in the first column, X, is 2.5, 3, 3.5, and 4. And then my entries in my Y column, you see, are 142.5, 171, 199.5, and 228. So what I need to do here is use that information in my table here to see if I can figure out a rate for Steve. So I am going to find Steve's rate, and so I want then to go ahead and use that form of the distance formula where R equals D over T. So then I can find Steve's rate by replacing the D. I picked 171 miles from that chart, which corresponded to 3 hours. So then on my calculator, when I divide 171 by 3, I get 57. So Steve's rate is 57 miles per hour. Now I'm going to my second page. So now then I can compare Jack's speed of 60 miles an hour and Steve's speed of 57 miles per hour to answer question A. So we can see then that Jack drives at a greater speed because 60 is larger than 57. All right, now I'm going on to part B of that problem. It says write an equation for a third driver, Susie, who drives half as fast as Steve. Use Y to represent the number of miles Susie travels in X hours. Explain. So if Susie's rate is half as Steve's, I can go ahead and find her rate by taking Steve's 57 miles per hour and dividing that by 2. When I do that, I get 28.5. So I know Susie's rate then is 28.5 miles per hour. So the equation I'm going to choose is the form where D equals R times T, which you can see I've written here, and I'm going to highlight that with my orange marker here. So then if I replace the R with Susie's speed of 28.5 miles an hour, I get in this form D equals 28.5 T. But the question says to write that equation in terms of Y and X. So then you just want to replace the D with the Y variable. The Y-axis is always represented with your distance. Your X-axis is represented with time. So then your answer is going to look something like this. It's going to be, instead of D equals 28.5 T, it's going to say Y equals 28.5 X. Now, I did kind of a quick sketch of that just so you understand how to do it. So you see on my X-axis, I'm counting by ones. Because, you know, when we write the equation, 28.5, that's the rate she's driving at. That's your slope. Remember your mathematical definition of slope. Slope is a rate of change. So since her rate is 28.5 over 1, remember on the formula, the 28.5, that's your change in your Y-axis, your Y variable. And then the 1, that's your change in X. So I can count on the X-axis by 1, which you see there, 1, 2, 3, 4, and 5. My Y-axis, I'm counting there, you can kind of see that by tens, 10, 20, 30, 40, 50, 60, 70, 80, 90. The reason I did that is because it would be pretty easy for me to get an estimate about where the 28.5 for Susie falls. So I went along the x-axis to 1, and then on graph paper, there'd be like a bluish line. I'd stay on that line until I got close to the 30 and I put a dot there. Now from that dot, right, I can go over one more unit, so I would be at 2, right? I'm gonna illustrate that with the orange. And then I go up 28.5, and I'd be at that second dot there. So, you know, for 2 hours, she will have driven 57 miles. Now I can even get one more dot, right? So from here, I'm gonna go over 1 unit to 3, and then go straight up here, another 28.5, and then that will put me right there at the 86, all right? So then I have those 3 points, and then when I connect those, and if you want to use a ruler, I probably should if I didn't, you can get a little bit better, straighter line than I have. That's going to go through the origin, right? Because if she hasn't been driving for any amount of time, she will not go any miles. So that's a pretty good graph to represent Susie's rate in that equation of y equal 28.5x. All right, guys, then for D, part D then, there's my slope right over here, and that's 28.5 because that's the rate that Susie's traveling. Remember, slope is the rate of change. So that's how much distance she's changing, right, for every hour that she drives. All right, hope that helps, and talk to you later.